Hey, y'all. How's it going? Rosendo from MLH here. As y'all already know, Global Hack Week October is well underway, and we've got a huge treat for y'all today. We're going to be learning about Elasticsearch and Kibana, part of the Elastic Stack, and we're going to be bringing on one of its foremost experts. Hopefully, I am not overselling your skills here, Lisa Jung, but we do have a senior developer advocate from Elastic joining us today to espouse all of the beautiful and wonderful benefits of Elasticsearch and Kibana. So you've got that in store. Outside of that, I want to say happy Diwali to everyone joining us from the Asia Pacific, from India. Happy Monday to everyone else that is joining us from all over the globe. So yeah, if y'all are excited, let me know in the chat. And yeah, we can get started. So yeah, hello everyone. Thank you for your greetings. With that said, I'm gonna go ahead and bring Lisa onto the stream. So y'all make sure that you give her a warm welcome. All right, welcome, Lisa.
Hey, thanks, Rosendo.
No
Hi,
worries.
everybody. Yeah. All right. So thank you so much for having me here. Again, my name is Lisa Jung, and I'm a developer advocate at Elastic. So today I'm going to give you an intro to Elasticsearch and Kibana and how you can perform CRUD operations with these two products. So before we get started, let's kick this off with a question. Have you ever used the Elastic Stack before? So type yes in the chat if you have used it, or type no if you haven't. All right. Okay, so it seems like majority of you haven't used Elasticsearch before, but even if you haven't, you may be using a lot of apps with certain features that are powered by the Elasticsearch. So for example, if you've ever searched for a ride on Uber, Elastic is the engine that powers the Uber marketplace that connects you to the driver. If you ever had mad cravings for tacos and were searching for open restaurants on Yelp, Elastic is powering that search. So it's hidden under a lot of the apps and websites that you use on a daily basis, which few of them are shown here. So what is the Elastic Stack exactly? Now, if you're a developer working with data, the Elastic Stack is a great tool to have on your belt. It consists of three parts: Elasticsearch, Kibana, and integrations. And with the stack, you could take data from any source, any format, then search, analyze, and visualize in real time. So some of the most popular use cases for the Elastic Stack are logging, metrics, security analytics, and business analytics. For example, the Elastic Stack is used to store and analyze log data. And a specific example for all the gamers out there, Blizzard uses the Elastic Stack to analyze gamer and server events. So if the players experience a slowdown or an error, their monitoring team would use the Elastic Stack to figure out what's causing it. Now, it could also be used to gather metrics. So one of my favorite examples is the Mars Curiosity rover. It sends telemetry, sensor, and photo data into the Elastic Stack for analysis. So if someone wanted to know how hot Mars is on an hourly basis, you can go and pull the data. Now, with the Elastic Stack, you could analyze security issues and threats within an environment as well. So you probably have used Slack at hackathons or at student groups before. And what you may not realize is that Slack uses the Elastic Stack in their security operations center to secure communications through their channels. Now, lastly, if you have ever used Tinder, you probably didn't realize that the Elastic Stack was helping you find your match. So this is a technology behind using geolocations to match people together. And it's also used to analyze business needs and build custom applications so you could analyze and learn from the data. For example, Tinder relies on the Elastic Stack to analyze and predict which people a user will swipe right on, or which people will swipe right on that user, and when there's a match. Now, all of these use cases are made possible by the Elastic Stack. And with a stack, you could take data from any source in any format, then search, analyze, and visualize in real time. So it's a collection of three parts. First, we have Elasticsearch, which is the heart of the Elastic Stack. It allows you to store, search, and analyze your data. Then we have Kibana, which is a visualization tool, and it's a UI that helps you visualize and explore data in Elasticsearch. Then we have integrations. Integrations allow you to ingest data as well as connect to all the systems that matter. You could also send alerts to the notification tool of choice. So today I'm going to give you an intro to Elasticsearch and Kibana and how you can perform CRUD operations with these two products. Here's a game plan. We'll start by going over a scenario where Elasticsearch and Kibana could come in handy. Then we'll go over the basic architecture of Elasticsearch, and we'll wrap up by running CRUD operations with Elasticsearch and Kibana. All right, so let's get started here. So Elasticsearch is known as the heart of the Elastic Stack, and this is where you could store, search, and analyze your data. So let's go over a scenario where Elasticsearch may come in handy. So imagine you're a lead developer responsible for building and maintaining an online grocery shop. And using the search bar, millions of customers will be searching for products that they want to buy. Now, a great search experience is key to have your customers to buy and keep coming back to your platform. And we want the customers to get fast and relevant results no matter the scale. Now, another important factor in search experience is relevancy. So the whole point of search is finding relevant data fast. And we want to be able to fine-tune our search experience to get the information that we want. We also want most relevant results at the top and the least relevant at the bottom. For example, let's say a customer is searching for peanut butter and there are a ton of different brands. But what if a customer wanted to see peanut butter from highest to lowest rated brands? Or what if the customer is searching for sriracha hot sauce and misspells it? Well, we still want to pull up relevant results, even though the customer spelling doesn't exactly match the product data. So if you're in a situation where the speed and relevance of your search is an important aspect of your work, Elasticsearch could come in really handy. So how does it look when Elasticsearch is connected to your app? Well, when a user sends a search request from your website, the request is sent to the server, which sends a search request to Elasticsearch. Then Elasticsearch finds the results and sends these back to the server, which processes the info and sends the results back to the browser. So let's go even one step further. So through your app, you're collecting a lot of data, such as order information, purchase history, and the list goes on and on. And we want to make use of that data. For example, we want to know what was the revenue for the last month, or which products are most popular. To answer these questions, you could enter relevant data in Elasticsearch so you could search and analyze your data to answer your questions. But data is so much easier to understand if you could visualize it. And this is where Kibana comes in, which helps you to visualize and manage your data. So think of Kibana as a web interface to the data stored in Elasticsearch. It allows you to search, view, and interact with your Elasticsearch data. So if you had a question about what is the most popular product, or what was your revenue last month, you would enter relevant data in Elasticsearch. Then from Kibana, send requests to Elasticsearch to get and analyze the data you want. Now, on top of that, you'll be able to create a dashboard with Kibana. So you could visualize data in a variety of charts, tables, and maps. So this way, you can gain insights more easily and be able to share that with your stakeholders. So if you're in a situation where you need to analyze and visualize data inside Elasticsearch, Kibana will come in really handy. Okay, so now that you understand when to use Elasticsearch and Kibana, we'll move on to the basic architecture of Elasticsearch. Now, as you know, Elasticsearch, Kibana, and integrations make up the Elastic Stack. Now, among these, Elasticsearch is considered as the heart of the Elastic Stack, and it serves as a powerful search and analytics engine. Now, it's also known for its distributed nature, speed, and scalability, and this is due to its unique architecture. So when Elasticsearch is up and running, you now have an instance of Elasticsearch, also known as node. Now, each node has a unique ID and a name, and it belongs to a single cluster. Now we'll get to what that is in a little bit. Now, when you start up a node, a cluster is formed automatically, and you could have one to many nodes in a cluster. And these nodes are distributed across separate machines, but they all belong to the same cluster and work together to accomplish a task. So let's really bring this concept home. So think about a team that you have been a part of, and your team consists of multiple members who all work together to accomplish a common goal. Now, your team could divide and conquer by assigning each member one or multiple roles. And now, your team members may work in different buildings, but you all still belong to the same team. And this analogy directly applies to nodes in a cluster. For example, nodes are members of a cluster that share a common goal, and nodes are distributed across separate machines, but they're still a part of the same cluster. Now, nodes are assigned to one or multiple roles, and one of the roles that a node could be assigned to is to hold data. And that is what we'll be focusing on today. So, data is stored in Elasticsearch as documents, and a document is a JSON object that contains whatever data you want to store in Elasticsearch. So, let's say we're running an online grocery shop app, and we're helping our customers to search for grocery items online. So we need to store grocery data in Elasticsearch. Now, a document for one grocery item would look like this. So in a JSON object, it contains a list of fields or key value pairs. So for example, it has the name of the product, the category it belongs in, its brand, and price. Now, things are easier to find when you group them in a logical manner. And documents that share similar traits and are logically related to each other are grouped into an index. So, for example, documents of clementines and carrots would be grouped under the produce index. Documents of wine and IPAs would be grouped under the wine and beer index. So, to sum up, indices are used to group documents that are related to each other so we know where to find certain information. So let's delve into this a little bit more. Here we have a cluster of nodes, and we have a produce index and wine and beer index. Now here, the index is not actually storing documents. It's just a virtual thing that keeps track of where documents are stored. Now you can't find the index on the disk. What actually exists on disk is a shard. Now, shard is where data is stored, and this is where you run a search. Now, when you create an index, one shard comes with it by default, and you could also configure it so that you could create an index with multiple shards that are distributed across nodes. Now, this is a practice called sharding, and a lot of superpowers that come with this practice. So let's say you have a cluster that looks like this, and you want to create a produce index that will keep track of all produce documents. Now, when you create an index, one shard is created by default, and the shard is assigned to a node. Now, remember, shard is where documents are stored, and the number of documents shard could hold depends on the capacity of the node. So let's say you want to index 600,000 documents in your produce index, but the node where the shard is assigned to could only hold 200,000 documents. Well, that's not going to work, right? But we do have two more nodes which could hold 200,000 documents each. So what you can do is you could add two additional shards in an index and distribute them across these nodes. Now each shard could hold 200,000 documents, so together they could hold 600,000 produce documents. Now, it's all fine and dandy, but our produce data is only going to grow. So how are we going to adapt to increasing amount of data? Well, that is the beauty of sharding. Now, you could add more shards and nodes as the need arises, so you could horizontally scale and adapt to increasing amount of data. But that's not the only superpower that comes with sharding. Now remember, shard is where you store documents, and it's also where you run search. So let's talk about a scenario where the client is sending a search request for pink lady apples. Now, in this scenario, you only have one chart in a node that could hold the entire produce index. So let's say this produce index keeps track of 500,000 documents, and we're going to run a search in this single shard, meaning we'll go through 500,000 documents sequentially. So let's say it takes you about 10 seconds to do that. Now, this time we're going to run the same search with a different setup. So we have 10 shards distributed across 10 nodes, and we distribute 500,000 documents across 10 shards so that each shard holds 50,000 documents each. Now, in the previous scenario, it took us through 500,000 documents. Now, what's so cool about this setup is that you could run a search on all 10 of these shards at the same time in parallel. Now, guess how long it takes to search through 500,000 documents with this setup? 1 second. So as you can see, sharding could really speed up your search. Now, with the first setup, one node had to store all the info and process all incoming search. And with this setup, we could only store as much data and process search requests as a single machine. Now, with the second setup, we distributed data across shards and allow shards to process search requests in parallel. So not only do we have the capacity to store more data, we can now search at scale. Now, let's say everything is going well with our online grocery shop, but all of a sudden, one of our nodes goes down and our data is lost forever. That would suck, right? And we want to avoid this at all costs. So, what we could do is we can make copies of the original shards and store its copies across different nodes. So, look at nodes 1 and 2. These nodes contain our original shards, also known as primary shards. That is what P stands for. Now we're going to make copies of each shard and store these in nodes 3 and 4. Now these are known as replica shards, and that is what R stands for. So R0 is a replica shard of primary shard 0. R1 is a replica shard of primary shard 1. So what this does is that if one node goes down, everything is okay because we have a replica of our data somewhere else. Now, that's not all. There's an additional superpower that comes with replica shards, and that is improving the performance of your search. So let's say we have 2 primary shards distributed across 2 nodes. You're currently getting 2,000 search requests per second, and these search requests are being ran in these 2 primary shards. Now, as our app is getting more popular, the search requests have now increased to 8,000 requests per second. Now, because of that, your 2 primary shards are having trouble keeping up with the demand. To solve this, you could add more nodes and increase the number of replica shards of P0 and P1. Now remember, these replicas are identical copies of the primary shards. So with a new setup, these replica shards could pick up the slack, and your cluster could better handle increased demands on search. All right, so now that you understand the basics of Elasticsearch, we're going to move on to the tutorial. The goal of this tutorial is to get familiarized with CRUD operations. In other words, how do we create, read, update, and delete a document from Elasticsearch? So to do this, we're going to use Elasticsearch and Kibana. Now, there are multiple options for accessing these 2 products. So one option is to use Elasticsearch and Kibana hosted on Elastic Cloud. And it handles all the heavy lifting of managing the stack so you can focus on the product that you're building. So I believe you have a 4-month trial, and there's no credit card required, and the trial expires on its own. And I find that for beginners, it's easier and faster to get started with Elastic Cloud. So I'm going to show you how to do that today. And we'll be sharing the link to the Elastic Cloud trial in the chat. All right, so let me show you how you can access Elasticsearch and Kibana through Elastic Cloud. Now you see the link on the top of the screen there. Now this is a go-to link for all the resources I'll share with you. And this link will also be shared via chat as well. Now you'll go to this link and click on part 1. And it'll take you to this repo here. Now the link to the free Elastic Cloud trial should be, yep, it has been shared with you just now in the chat. So when you click on that link, you'll see this free trial page. Now I'm going to breeze over this setup. You could always watch the recording later if you want to try this out on your own. So first, click on try it free option. And once you do that, it'll prompt you to enter your email and password and start your free trial. Then the page, Then the page will prompt you to create your first deployment. So name your deployment to whatever it makes sense to you. I'm going to name my mini beginner's crash course. Then click on edit. Now this will give you options to configure your deployment settings. First, you would choose a cloud provider of your choice. So let's say you have an app and you want to integrate it with Elasticsearch. But if your app is running on Google Cloud, you don't want Elasticsearch running in a different cloud provider because that'll cause latency issues. But for what we're about to do, it doesn't matter which one you choose, just select one. Afterwards, select the region close to you. Then select your hardware profile. So Elasticsearch offers several deployment templates for different use cases and workload. And each template selects the appropriate cloud hardware configuration for different needs. But if you're just getting started or don't quite know your needs yet, then go with the storage optimized option. Then select the latest version of the Elastic Stack. I believe the most current one as of today is 8.4.3. Now, once you have configured your setting, click on Create Deployment option. Then the creation of deployment should take about 5 minutes. Now, meanwhile, it'll display the deployment credentials here. So save the credentials somewhere as these are only shown once. Then click on the Continue option. Then click on Explore on My Own option. And this option will take you to the Kibana homepage. Now, when you click on DevTools, it'll take you to the Kibana console, and you'll click on Dismiss and delete the default query shown here. And now we're ready to use Kibana to send requests to Elasticsearch. All right, so let's do a quick review before we get to the CRUD operations. Now remember, Elasticsearch is a search engine. And when a user sends a search request from your website, the request is sent to the server, which sends a search request to Elasticsearch. Now, Elasticsearch will find the info, then send it back to the server, which processes the info and sends the results back to the browser. Now, the same process can be mimicked and tested with Kibana, which is a UI that communicates with Elasticsearch. And when you deploy on Elastic Cloud, Elasticsearch and Kibana are automatically prepped and ready to go. And the cloud automatically creates multiple nodes that are grouped into a cluster. Now, as you know, Elasticsearch is receiving search requests and sending the results back all the time. And this communication is handled by HTTP requests. Now, in the tutorial, we'll be learning about HTTP requests we could send to create, read, update, and delete data in Elasticsearch. All right, so let's get organized here real quick. All right, so we have two windows open side by side. On the left, we have the DevTools open, also known as a Kibana console. On the right, we have the Part 1 repo open. Now, this is the same repo we used to get the link to the free cloud trial page. And I've scrolled down to performing CRUD operations section here. So let's go to the window where we have Kibana console open. So this is divided into two panels. So on the left is where we enter the request we want to send to Elasticsearch. On the right is where we'll see the response from Elasticsearch. So we're going to learn about requests you could send to perform CRUD operations. So in other words, how do we create, read, update, and delete a document? So for this exercise, we're going to store documents about our favorite candy. Now, by now, you know that documents are logically grouped into an index. And as a best practice, we're going to create an index first. So to create an index, we use a HTTP verb put followed by name of the index. And since we're indexing documents about our favorite candy, we'll name our index favorite underscore candy. So let's copy and paste that into the console. Make sure to select it and send. Now, to your right, you'll see the response from Elasticsearch. And when you see acknowledged equals true, it means that an index called favorite candy has been created. All right. So now that we have an index, let's index some documents. Now, this time I'm using index as a verb to mean that we're storing documents in Elasticsearch. So let's scroll down to index a document section here. Create part of the CRUD operation. So when you're indexing a document, you could use post or put. Now you would use post if you want Elasticsearch to auto-generate an ID for your document. So the syntax that you're going to follow for that is post followed by name of the index, then the document endpoint, followed by a JSON object with whatever data that you want to store in Elasticsearch. So in our example, what we're saying is post in favorite candy index the following document, and our document has two fields called first name and candy. So let's copy and paste that into the console. Make sure to select and send. Okay, so to your right, you'll see a response from Elasticsearch. You see 201 here, which tells you that the request was successful. And if you look closely, you'll see that in the index favorite candy, a document with an auto-generated ID has been created. Now, turn to your repo and scroll up to index a document section again. And here it says when indexing a document, both HTTP verbs post or put can be used. Now, we just went over post, so let's go over when you would use put to index a document. So scroll down to put here. Now, you would use put if you want to assign a specific ID to your document. Now, a time where you might want to use this is when you're indexing data with a natural identifier. So, for example, let's say you are working with a hospital and you're indexing patient data where each patient has a unique ID. Now, documents may be easier to work with if they have the same ID as a patient ID rather than an auto-generated ID that has no meaning, because it's easier to keep everything uniform across multiple data sources. So this time, we're going to index a couple more documents using put. So if you look at the repo, you'll see that this request starts with put, followed by name of the index, the document endpoint, then the ID that you want to assign to this document, followed by whatever data that you want to index into Elasticsearch. So what our example is saying is put in favorite candy index the following document and assign this document an ID of 1. So let's copy and paste this into the console here. Make sure to select and send. Now, again, you'll see a 201 success response, and it tells you that in the index favorite candy, a document with an assigned ID of 1 has been created. Now, you'll see that the version number here is 1. We'll go over what that is in a little bit. Okay, so I'm going to index a couple more documents. So I'm going to copy and paste this exact request twice below. Now, I'll say that in document with an assigned ID of 2, Rachel's favorite candy is Rolo. I'm going to select and send. And you'll see that this document has been successfully created here. Now I'm going to create a document with an ID of 3. And I'll say Tom's favorite candy is Kit Kat. Again, document with an ID of 3 has been successfully created here. Okay, so we've so far indexed 3 documents using the put request here. And I want to send a request to see the content of the document that has been indexed. So this is R, the read part of CRUD operations. So turn to your repo and scroll down to the read section here. Now, the syntax that we're going to use is get followed by name of the index, document endpoint, and the ID of the document that you want to retrieve. So in our example, what we're saying is get from favorite candy index document with an ID of 1. So let's copy and paste that below document 1 here. Make sure to select and send. And you'll see that from the index favorite candy, document with an ID of 1 has been retrieved. And if you look under the source field, you'll see the same information that we indexed. This is a great way to check whether our CRUD operations have worked or not. So now, what do you think would happen if we accidentally index another document with an existing ID? So let's find out. So we'll go to the request for document with an ID of 1. I'm going to copy and paste this request below. So let's say Sally's favorite candy is Milky Way. But I accidentally forgot to assign a different ID. And I indexed this document with an existing ID of 1. So I'm going to send this request here. All right, so this looks a little different. You're getting a 200 response instead of 201 that we usually get. Now in line 5, you'll see that this has been updated. Now let's take a look at the version number here, which has been changed to 2. So what this version number is telling you is the number of documents this document has been either newly indexed, updated, or deleted. So far, we indexed this document with John's info. Then we accidentally updated it with Sally's info. So therefore, the version number is now 2. All right, so let's send a GET request to see the content of document with ID of 1. We'll use the same request that we sent earlier. Just make sure to select it and send. Now, if you look under the source field, you'll see that John's information has been accidentally updated with Sally's information. Well, that's not good, right? Because when you're indexing your data, you don't want to accidentally overwrite your existing document. So in order to prevent that, you could use the create endpoint. So turn to your repo and scroll up to that section there. Now, the syntax you use is put followed by name of the index, then the create endpoint, then the ID that you want to assign to the following document. So what our example is saying, put in favorite candy index the following document and assign it an ID of 1. However, if this ID already exists, then don't do anything. Just throw an error. So let's copy and paste this below the GET request here. Make sure to select and send. Now, this is what we're looking for. So you'll see a 409 error message. And in line 6, you'll see the reason for that is because the document already exists. So the create endpoint worked just as it should. Let's just double check and take a look at the content of document with an ID of 1. So we'll go back to this GET request we've been sending here and send it. Now, if you look at the source field, you'll see that Sally's information is still there. So the create endpoint provides a safeguard for you so you don't accidentally overwrite your document. Now let's scroll down to update. So there will be times when you'll want to update an existing document. So for example, let's say Sally originally liked Milky Way, but she changed her mind. Her favorite candy now is M&Ms. So let's go back to our repo. So to update a document, the syntax you'll use for that is post followed by name of the index, then the update endpoint, then the ID of the document that you wish to update. Now in the JSON object, make sure you add doc as a context here. So what this is telling you is to only update the fields specified in the inner brackets here. So in our example, what we're saying is post in favorite candy index. I want you to update document with an ID of 1. But please note that I only want to update the field candy with M&Ms. So let's copy and paste this right below the request for Sally's information here. Make sure to select and send. Now, you'll see that in the index favorite candy document with an ID of 1 has been updated. Now 3. Now that makes sense because we first created document 1 with John's information. Then we accidentally updated with Sally's. Then we intentionally updated the field candy with M&Ms. So let's make sure document 1 has been correctly updated. So let's go back to the GET request that we've been sending. Make sure to select and send. Now you'll see that document with an ID of 1 has been retrieved, and Sally's favorite candy has been updated to M&Ms. Now, last but not least, what if we want to delete a document? So that one is super simple. So scroll down to the delete section, and the syntax you'll use for that is delete followed by name of the index, document endpoint, then the ID of the document that you want to delete. So in our example, we're deleting from favorite candy index document with an ID of 1. So let's copy and paste that below this request for M&Ms here. Now you'll see that a document with an ID of 1 has been deleted and the version number is now 4. Now, if you send a GET request again for document 1, you'll get a 404 error because document 1 no longer exists. All right, so those are all the requests that I got for you. I know we went through a lot, so let me see if you guys ask any questions in the Q&A section. 1 second. Oh, okay, thank you. Okay, so I see a question that says, can we add hashing kind of principle with sharding? I'm not really familiar with the term hashing. Can you talk more about that? Feel free to put it in the chat or Rosenda, can they unmute themselves? Hello? Oh, okay. So audience cannot. Okay. Well, that's a bummer. Could somebody or could you explain what you mean by hashing? Like without understanding that term, I'm not sure if I could give you a relevant answer. All right. Well, for now, we could skip that question and move on to the next one. What's the next question? Okay, so considering this, theoretically, if we add 100 nodes for starting 500,000 documents, it would take around 0.1 second to scan five. Yes, but we wouldn't really recommend having 100 nodes for that uh, small of a load. Yeah. All right, next question, please. Was that it, Rosenda, or were there more? All right. Okay, so if there aren't any more questions, I've got some resources for you for me to share. Okay, so if you're interested in learning more, here are the resources that you should check out. So today's workshop is actually part one of the beginner's crash course to Elasticstack. So this is a full-length workshop where I help you get started with the Elasticstack. So start with part two if you want to continue learning. Now, many of beginners crash course to Elasticsearch and Kibana are short 10-minute clips on how you can get started with Elasticsearch and Kibana. So I've broken down the same beginner's work. If you prefer learning in bite-sized pieces, start with this one. Now, I also launched season 2 of Mini Beginners Crash Course, where we go over how to build a full stack JavaScript app with Elasticsearch and how to visualize data with Kibana. So feel free to check that out as well. And if you have any questions about Elastic, the discussion forum is a great place to get your questions answered. And we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your question here as well. All right, that's a wrap for me. So I will kick it back to Rosendo.
Thank you so much, Lisa, and thank you so much, everyone, for joining us. If there are no other questions, I will go ahead and relieve you of your duty of being here, Lisa. Thank you so much once again, y'all. I really appreciate it. Take it easy. All right. Well, with that being said, I did want to say that there are a ton of different challenges that Elastic will be hosting throughout the week. Particularly, you're going to want to check out the one from today. So go ahead and head over to ghw.mlh.io/challenges and check out the ones that are listed under sponsors, because that's where you'll find a lot of cool stuff. Once again, if you're going to want to go ahead and to get signed up with Elastic for free, it is no credit card required. The free trial just runs out, so you don't need to go in and renew your subscription or get accidentally charged or anything like that. Go to hackp.ac or hackpack/GHW oct elastic, and you're gonna have everything you need to do. You're gonna have everything you need to get started there. Yeah. Do we have to do these crash courses for completing our challenges on day 2? Check out the challenges that are available today. It will outline every single requirement for the challenge itself, and yes, it would be simply, I believe, deploying the that same instance of Elastic that we actually walked through earlier today, or earlier in this workshop, pardon. And yeah, the recording's going to be up, so no worries there. If you need anything, feel free to drop any of the questions that you have in chat in Discord. And huge shout out to Wei for helping out today. Always a pleasure to see you here, buddy. And outside of that, everyone else that joined us, thank you once again. That's it for me, Rosendo, signing off. Huge shout out to Elastic once again. We'll see y'all again later, and just stay tuned because we're going to have a lot more stuff coming at you about Global Hack Week October. All right, y'all. Take it easy.